we're going to get here, guys, is a particle is at the top of the outside surface of a smooth sphere of radius r. The particle is projected horizontally with initial speed of root a half gr. Find the angle which the normal of the sphere which the normal to the sphere at the particle makes with the vertical when the particle leaves the sphere. Okay. Which the normal of the sphere at the particle makes with the sphere when the particle leaves the sphere. Find also the speed of the particle when it leaves the sphere. Okay. So look, what we have here, guys, is we have a big circle and we have a particle on top of it, like a little sphere in its own right. You throw it off. Now, what's going to happen is it's not going to get down here. Everyone understand that? What's going to happen is it's going to reach here, and then it's going to be bye. It's going to fly off the edge, and then it's going to drop naturally under gravity. Yeah? So, what we have is we have the start of the question where you're on top, and then we have the end, the finish of the question, you're about to exit it, and then we have a tangent to that circle where we can get the angle at which it exits. Okay? So, sorry, but we're not looking for angle. We want to find the angle which the normal to the sphere at the particle makes with the vertical. So this is the normal to the sphere right here. So what I want you to find out is what is theta. That's what that language means there, okay? What is theta? So what we're going to do is, I'm going to do it slightly differently from the book, alright? The book, or the solutions, what they've decided to do was they took, do you remember I was telling you that you have to specify a point at which there's no potential energy, right? In the last question we did it down here, at the bottom of the sphere. What they did was, they did it at the centre. Now it actually works out the same, but I'm going to do it from the bottom to prove that it works out the same. Now why do you think they got away with doing it at the midway point? Because there's no chance that that ball can travel below the line. It's going to fall off before it reaches there. That's why you're allowed to do it for this particular question. We're going to keep it the same. We're just going to always just put at the bottom. Okay? Unless there's a special circumstance. So here's what we're going to do. We're going to start resolving our forces. Okay, so what is keeping the ball at the start of the question? What's keeping the object on the sphere? Reaction force R and its gravity of what's it, mg? Is it just a particle of mass m? So its mg is working directly down. Everybody happy with that? To start the question, R up, mg down. Now, what happens as the ball starts coming across here? What's going to happen then? R is still going to be acting directly out, perpendicular to the surface, along the line of the radius. Alright? What about its weight then? It's mg, going directly downwards, isn't it? So what we're going to do is we're going to resolve that. Remember I told you that you're going to resolve that along the radius. So we're going to get theta, 90 minus theta. Same as question 1. So just for that, so that's going to be mg cos theta and mg sin theta. Okay, if you don't understand that, you're going to have to look at question 1, video on question 1, okay? Where I went over in detail. Now, what we're going to do next is we're going to do our FC. So what is your FC? What is driving it directly in? Anybody? What force drives it towards the centre? mg cos theta. Okay. What's m again? We don't know. Phi squared, anybody? Do we know? Phi squared is what we're figuring out. What is its speed as it flies off the edge. What you're talking about is its initial speed when it kicked off. It's going to get faster because gravity's going to be working with it, and then it's going to go flying off the edge. Okay, so that's just going to equal mv squared. Do we have any idea what the radius is? Just r. Okay. So I'm just going to keep mv squared again. I like to keep it as mv squared always. So it's going to be r mg cos theta. That there is equation A. Ever happen with that? Equation A. Now, what about equation B, guys? Equation B. Potential energy at start. Called it R and another R. How high are you above the ground at the very beginning? Sorry? 2R. So potential energy is going to be mgh, mass times gravity times 2R. Potential energy 1/3. What's kinetic energy again? A half mv squared. But you're given the initial velocity. So what's the initial velocity? What's phi again? You told me earlier. Half gr. Square root of half gr. So when you square that for your mv squared, remember it's a half mv squared for kinetic energy. What you're going to get is, you're going to get a half times a half gr, because you're squaring this here. Everybody alright with that? Now you've done your kinetic energy at the beginning of your question. Kinetic energy at the beginning of your question is now done. What is the potential energy at the end of your question? Potential energy at the end of your question. How far are we above the ground? Remember what I told you in the first question? You bring the black dot across, and you want to find out this height here. And now that I'm done with all these forces, what I can say next is that it's just simply going to be r plus r cos theta. So you're right about that being, you're right, that's r. You're right about that black line being r cos theta. But remember I said I'm taking it above the bottom of the sphere. So it's r plus r cos theta. So mg r plus r cos theta. Everybody alright with that? mgr plus r cos theta, because that's your potential energy too. Your mgh formula. Remember, mass by gravity by height. Your height is r plus r cos theta. Now guys, what is your kinetic energy at the end? That's the whole point of the question, isn't it? A half mv squared. If we isolate mv squared, we can then compare it to the equation to the right. Here's what we're going to do. I'm going to multiply, I'm going to get 2 mgr, I'm going to get a quarter mgr, I'm going to get this is going to multiply out to become mgr, and when I bring it over that side, it's going to be minus mgr. That's going to become a minus mgr cos theta, and that's still going to be a half mv squared. Now, what I'm going to do next, guys, is 2 plus a quarter minus 1 is 1 plus a quarter, which is 4/5 mgr minus mgr cos theta equals a half mv squared. I'm going to multiply everything by 2. When I multiply everything by 2, that will become 5/2. That will become 2 mgr cos theta, and this will simply become mv squared. Now both equations are now comparable with each other. Okay? Now, I'm going to have rmg, so mv squared equals mv squared is basically what I'm doing here. So I'm going to have rmg cos theta, same thing as mgr, so look, I'll change rmg to mgr just to keep it compatible. Okay? And then one thing. On the top equation, yeah. Remember I said that the weight. Remember I said that the weight was acting towards the centre, I forgot to take away, or plus the reaction force is working against it. So remember we had the diagonal left, that's diagonal left down. I forgot to take away the R, which is diagonal right up. Okay, so that's mgr cos theta minus capital R.
You have to multiply that by R as well, because when you brought the R at the start.
Oh, so what do I have to do?
Go to the top where you had mg cos theta.
Ah, you're right indeed. So that's mgr cos theta, mg cos theta. Whatever that goes. That's mg cos theta. That was going in the diagonal right down, and the R was supporting it, acting diagonal right up. And then we were saying it's going to cross multiply by R, that should be R smaller. Thank you. Okay, so what we're going to have is Rmg cos theta minus R small r equals 5 over 2 mgr minus 2 mgr cos theta. Now what can you get rid of here, guys? Sorry? Little r's. Bring the mg cos theta over your side. We're going to get minus r equals 5 over 2 mg minus 3 mg cos theta. Now, when you're going off the edge of a circle, you're supported at the start. Remember, R always aims back in towards the centre of the circle. So, you're basically here, and now what happens is you're travelling across on the outside, and all of a sudden you lift off the edge. What happens when you leave the surface? What happens to the R value? R value turns to 0 just as you leave the surface. So 0 equals 5 over 2 mg minus 3 mg cos theta. The mg's will now cancel, so we get 3 mg cos theta equals 5 over 2 mg. Mg's will cancel, cos theta equals 5 over 6. And when you inverse that, you're going to get 33 degrees 34 minutes. Okay. Now finally, it also wanted me to find out the velocity, right? So the velocity, which is the easy equation again, I'm going to use this one here. So this one here. Now that I know what cos theta is, bring this down for a minute. Now, what I'm going to do is I'm going to find out what phi is. It wants me to find out what the velocity is. So it's going to be 5 over 2 mgr minus 2 mgr cos theta, which is 5 over 6, equals mv squared. Okay, then the m's are going to cancel, and then it's going to be, what's it, 5, what's 5 over 2 minus 5 over 3? 5 over 2 minus 5 over 3, anybody? 5 over 6. So it's going to be 5 over 6. 5 over 6 gr equals phi squared. Phi equals the square root of 5 over 6, 5 gr over 6. Okay, that's that one done.